K-means had one demand we quietly skipped over. We had to tell it K, the number of clusters, before it could start. But how do we know the right number? Let's learn how to choose K with more than a guess. Here is the trouble. The very same customers can be split into 2 groups, or 3, or 5. K-means will obey whatever K we hand it. So which one actually reflects the real structure? Let's look at what goes wrong at the extremes. If we pick K too small, say, 2, the algorithm is forced to jam genuinely different customers into one group. Here, the big spenders and the frequent visitors get lumped together. Real, distinct groups are blurred into one. If we pick K too large, say, 5, we get the opposite problem. A single, perfectly good group gets chopped into meaningless slivers. We are now inventing distinctions that are not really there. Your first instinct might be to just use inertia, that total distance from points to their centroids that K-means already minimizes. Simply pick the K with the lowest inertia. But watch, inertia always falls as K grows. More clusters can always hug the points more tightly. Taken to the extreme, every point becomes its own cluster and inertia hits 0. Lowest inertia alone is useless. The trick is not the lowest point, it is the bend. This is the elbow method. Follow the curve. From 1 to 3 clusters, inertia plunges, each new group buys a big improvement. After 3, the curve flattens, extra clusters barely help. That corner, where the steep drop turns gentle, is the elbow. Here it sits at K equals 3, our sweet spot. A second, sturdier tool is the silhouette score. It rewards clusters that are both tight inside and well separated from each other, on a scale from -1 to 1. Unlike inertia, higher is better and it does not just keep climbing. We compute it for each K and pick the peak, which, again, lands on 3. One honest note, these tools suggest, they do not dictate. The elbow can be fuzzy, and 2 metrics may disagree. In practice you combine them with plain domain sense. Sometimes the business simply needs, say, 4 marketing segments, and that decides K for you. In scikit-learn it is a short loop. For each candidate K, we fit a K-means and record its inertia. That is the .inertia underscore attribute, then plot inertia against K and eyeball the elbow. For the silhouette, we call silhouette score on the data and the resulting labels, and keep the K that scores highest. To recap, too few clusters merge real groups, too many invent fake ones. Inertia always drops, so look for the elbow where it flattens, and back it up with the silhouette score, which peaks at a good K. Then temper both with common sense. Next, we'll dig deeper into judging how good a clustering really is.